Hey guys, this is Carrie, and this is the answer key for homework number 1 in Unit 2, Radicals. So for problem 1a, similar to the problem in class, I meant to have the square root initially starting over the entire fraction. So we have the square root of 25 divided by 16, which when you simplify it becomes the square root of 25 divided by the square root of 16 separately. Square root of 25 is a perfect square, which becomes 5. Square root of 16, 16 is a perfect square, so that becomes 4. So we have 5/4. For problem B, we've got square root of 135, and unlike the two square roots we looked at just now, square root of 135 doesn't have a nice answer. So we have to put this problem in simplest radical form. So we'll break 135 into its prime factors. It looks like 5 divides this, so we've got 5 and I think 27. 27 can be broken into 3 times 9, and 9 can be broken into 3 times 3. So when we factor 135 into its prime factors, we get 5, 3, 3, and 3. So the square root of 135 is the same as the square root of 5 times 3 times 3 times 3. So just like in class, we're going to be looking for twins. And so we've got 2 3's inside of the square root. One of the 3's becomes eliminated. One of the 3's comes out, and we get 3 times the square root of 5 times 3. That becomes 3 square root of 15, which is our final answer in simplest radical form. For problem C, I think that you guys can handle this based on what I saw in class. For problem D, we've got 3 square root of 25, and you might immediately jump to using simplest radical form like we did before, but you should remember square root of 25, that's one of the nice numbers. Square root of 25 is 3 square root, oh no, not square root, because we did the square root. 3 times 5. Sorry about the background noise. I'm recording this in 447, so there's some stuff going on. Next up, we've got the square root of -9. And just like we saw in class today, if you try this on your calculator, you'll get error non-real answer. Non-real answer. And so this actually has no answer. This is undefined. And you guys did a nice job of uncovering why this doesn't work out, right? We imagine that, well, what the square root asks is, what number times itself gives us -9? And there is no number that will do that, right? If we try 3 and 3, 3 times 3 is +9, so that doesn't work. Maybe -3 times -3, but negative times negative would also give us +9. So because none of these numbers work, our final answer is that this number is undefined and it's not actually a number. Next up, we get negative square root of 9. Square root of 9, it's a perfect square, right? So we just get 3, and then the negative in front, so we have -3 as our final answer. For problem 2, I think you guys can do part A and B. So I'm going to look at C and D. So for part C, we've got f of 40. So f of 40, 40 is our input. And so we input 40 into the function. And 40 isn't a perfect square, so this needs to be simplified using simplest radical form. So we'll do our factor tree for 40. 4 times 10, 2 times 2, 10 is 2 times 5. And so we broke 40 down into its prime factors, the smallest numbers that we can break it down into that make 40. That becomes 3 square root of 2 times 2 times 2 times 5. And to do simplest radical form, we look for twins, we look for groups of 2, so we have these 2 2's here. One of the 2's is eliminated, and one of the 2's comes out, so we get 6 square root of 10. If f of k is equal to 12, then determine the value of k. So this is one where k is the input, and 12 is the output. And so probably the best way to read this, just because we haven't seen one in a while, would be when k is inputted into the function, $12 comes out. And so that means that when we take k and put it into our function, it becomes 3 square root of k. The output is 12. And we hadn't done a problem like this in class, so maybe this is a little bit of an extension, but it prepares you really well for tomorrow's lesson. So let's solve for k. So to cancel out multiplication by 3, we divide by 3 on both sides. That leaves us with square root of k equals 4. And in class, we saw that like in the Pythagorean theorem problems, to cancel a square, we used a square root. So square roots cancel squares. But if square roots cancel squares, that means that the inverse is true as well. Squares cancel square roots. So this becomes k equals 16. So just to be clear, this part up here was just part of the explanation. It was not part of the problem. All right, moving forward. All right, this problem seems totally different, right? Instead of talking about triangles like we did in class, we've got circles. So the circle below has center 0, 0, and passes through the point 4, 6. Determine the radius of the circle in simplest radical form. So we've got our radius right here. I'm trying to think about what from class might be related to this. And I think the key observation is that you can actually build a right triangle really kind of straightforwardly by imagining graphing the point 4, 6. So if you graph 4, 6, let me do that, 4, 6, we have that this is 4 over and 6 up. And that actually makes a right triangle, since these are perpendicular, where we know 2 of the sides and we're trying to find the third. So let's use some cult mathematics, as we learned about the Pythagorean cult in class today, and bust out the Pythagorean theorem. So we have a squared plus b squared equals c squared. Substituting into the problem, we have 4 squared plus 6 squared equals, this time the hypotenuse is r, so equals r squared. 4 squared is 16, 6 squared is 36, equals r squared. R squared is equal to 52. Last step is to get r by itself. We square root both sides, and that gives us r equals the square root of 52. And you might think this is the final answer, but it's not the final answer, because you need to put it in simplest radical form. So 52, I know this from playing cards, can be broken into 4 times 13, because there's 4 suits of 13 cards. 4 can be broken into 2 and 2. And so we have r is equal to 2 times 13, all under the square root. And 2 times 2, that's a group of 2, so these 1 is eliminated, 1 comes out, and we get r equals 2 square root of 13. All right, next up, these are probably the 3 most important problems in the homework set, because instead of working with numbers like we have been, we're actually going to start working with variables. And so just like I did in class, if you're not sure how to do these problems, I encourage you to actually go the long route here and write everything out. So we'll start off doing it the long way and then see how this gives way to a shortcut. So x to the 8th. That means that we have x times itself 8 times. So 4, 5, 6, 7, 8. Y to the 6th power means that we have y times itself 6 times. Y times y times y times y times y. And z I'm actually going to leave off so that we start thinking about this without writing everything out. So I'll put a ... for the z. All right, so looking at the x's, since we have, since we have 8 x's here, we want to split them up into twins, into groups of 2. So if we have 8 of them, we're going to have 4 groups of 2. Because 4 times 2 gives us 8 total. From each of those groups, 1 escapes and 1 is eliminated. And so half of the x's that we started with, the first half, those all escape, so we get x to the 4th. And the second half of the x's all are eliminated. They all die, so we're not left with any x's there. It looks like I'm short 1 y for the next part, so let me add that y in. If we start with 6 y's, we're going to be able to form 3 groups of 2, right? Because 3 times 2 is 6. From each of those groups, half of them, the first one will escape, and the other half will die. So we get y to the 3rd, half of the y's that we started with come out, the other half dies, so we're not left with any y's inside. Now thinking about z, you want to picture this without actually writing it out. So if you had 5 z's, and I'm not writing it intentionally, if you had 5 z's all written out, you could form 2 full groups, and that would make 2 times 2, 4 of the z's, and you'd have 1 z left over. Now from each of those groups, the first half is going to escape, and the second half is going to be eliminated. So we'll have 2 z's escape, 2 of them are eliminated, and this last z that was unpartnered is still inside of the square root. So that's our final answer for this problem. And we want to start moving towards what we did with the z, which is thinking about the pieces with how to actually maybe writing things out. because it looks like a to the 900 in this problem down here, problem 6, might be pretty difficult. So looking at the next problem has a misleading start. It says square root of 3. Because 3 is the only number, I know that that can't be simplified, so I'll leave the 3 inside of the square root. For a to the 40th, we want to be thinking about this. We've got 40 a's all lined up. How many groups of 2 could we make with 40 a's? I think that's a really important question, and I think if you think about it, you'll see that you could make 20 groups of 2. So from those 20 groups of 2, the first half will be outside of the square root, and the second half is eliminated, and so accounting for the group that escaped and the group that died, we have all 40 of the a's. Now b to the 110th really pushes us even farther in this direction. So you might think, well, how many groups of 2 can I make with 110 b's? So 110 divided by 2, that gives me 55 groups of 2. So I can make 55 groups of 2, so that means 55 of those b's will escape. The other 55 are the second halves, just like with the a's, so the second half ones will die. And we get our final answer here. For the next problem, I think you guys can do it on your own. I just want to encourage you guys, don't actually write out all 900